Yep. May, June 2023, paper 6, variant 1. Hmm. Question 1. A student investigates the balancing of a meter ruler. Okay, he places the meter ruler at the pivot at 50 centimeters, at the 50 centimeter mark. Okay, with the scale facing upwards, he places an object Q with its center at the 90 centimeter mark. Can I find the distance y from the center to the 100 centimeter end? Okay, this is quite obvious because this is at 90 and the 100 centimeter end. So the distance would be 100 minus 90, which is 10 centimeters. Which is 10 centimeters. He places a load P, okay, 2 newtons on the meter ruler. He adjusts the position of the load so that the meter ruler is as near as possible to being balanced. He measures the distance x from the center of P to the zero end of the ruler. Okay, so he's measuring distance x and he keeps on repeating the experiment for different loads 2, 3, 4, 5, 6, and then describe. Okay, the main difficulty, it's hard to balance the ruler. Yes, it is very difficult. This is the main difficulty. So we have several difficulties in this experiment, but the main difficulty is that he cannot obtain an accurate balance. Okay, let me write it down. So he cannot obtain an accurate balance. Okay, next question. Plot a graph of Pn slash x centimeters. Okay, first of all, Pn on the y-axis. Okay, P slash n on the y-axis, x slash centimeters on the x-axis. So I took 1 out of 4 marks. Second of all, I need to scale the graph. On the y-axis, I have the P, which starts off with 2, 3, 4, 5, 6. You can write down 2, 3, 4, 5, 6. You can start off with 1 if you'd like. If you want to, you can start off with 2. Again, it's okay. 2, 3, 4, not 6, no, 5 and 6. And on the x-axis, you have 10.2 all the way up to 36.8. Okay. Can I start off with um can I start off with 10 all the way up to 36.8? So up to, let's say, at least 40. 10, 20, 30, 40. Okay, you maybe want to start with what if we start off with 10? Okay, let's use 10 on the x-axis, and on the y-axis you have 1 on this end, and on the x-axis and the y-axis you have 10, 20, 30, 40. Okay, I guess that's the only scale we can use. We cannot use 5. 10, 15, 20, 25, 30, 35. It would not be enough. Sadly, it would not be enough. Why? Because we have up to 36 point what? 36.8. So we cannot use a scale of 5. 5 would have been much better. Honestly, 5 would have been much better. But sadly, we'd only have to start off with 10, or if you'd like, you can start with 0. We can start with 0, 10, 20, 30, 40, and 50. Okay? You do not need to start with 0, but you can start with 0. Anyway, let's start plotting the graph. The first point is 2 and 10.2. Okay, cannot obtain an accurate balance. Okay, 10.2 and 2. So let's zoom in a bit. 10.2 would be, okay, 10, this is 11, so it's around here. Okay, and 2. Second point is 3 and 23.1. 3 and 23. Okay, so 23 and 3, which is here. 23 and 3. 30 and 40. Okay, that's easy. 30 and 4.0. 30 and 4.0. 33.8, which can be approximated to 34 and 5. 34, which is here, and 5. 34 and 5. And last point is 36.8, which is around 37 and 6. 37 and 6. So this is 37 and 6. Here it's. Can we draw a best fit line? Okay. Can I draw a best fit line? Yes, I can draw a best fit line. For this line, actually, this seems like a curve. This line actually seems like a curve. How should I know whether it is a curve or not? Okay. Should you know from the graph? Yes, you should know from the graph. This does seem like a curve. This does seem like a curve. Why? Because if you try to draw a straight line, okay, if you try to draw a straight line, this line wouldn't be um, a straight line wouldn't pass anywhere near most of the points. If we draw any straight line, it wouldn't pass anywhere near all of the points. So for this very specific curve, or for this very specific line, it would have been a curve, yes. A continuous curve. You have to draw a continuous curve. So it would be somewhat like this. Okay. This is a, you'd want to use a pencil definitely to draw a thin continuous line between, okay, that's passing through all of the points. That is passing through all of the points. No, this line is not using a ruler. Okay, this one is not using a ruler. Use the graph to find the value of x required to balance the ruler when p equals 3.5. When p equals 3.5. Should I connect it to 0? No, you should not connect it to 0. This will not even reach 0 at all. Okay, can I find x when p was 3.5? So from 3.5, let's draw a line. Okay, you have to draw a line. You have to show clearly on the graph that you have drawn a line. Okay, so if you draw the line from 3.5, this would be around, okay, 26. Some of you are saying 26. You might say 27. Some others might say 28. Again, just from the graph, okay, from the graph, whatever your point is, okay, 27 is okay, 26 is okay. And then draw another line downwards. Using the apparatus. Using the apparatus. Explain briefly how you would determine the position of the center of mass of the ruler. How can I find the position of the center of mass of the ruler? Ah, we said this difficulty before. How can I find the position of the center of mass of the ruler? Simply by just moving the ruler slowly until you find the center of mass. But you need to do that without any loads. So remove the loads. Just remove the loads and, okay, find the center of the mass. Okay, let me use the red color. Okay, remove the loads. Move the loads and move the ruler slowly until the center of mass is reached, or until you find the center of mass. Okay, can I measure it and divide by 2? No, you cannot measure it and divide by 2. Why? Because the ruler is 100 centimeters long, yes. And if you measure the ruler, the center of mass should be around 50 centimeters, which is true. But what if you have something? Okay, for example, there is 2 or 3 millimeters added to the ruler on each end, or on one end only, so the center of mass wouldn't be exactly at the 50 centimeter mark. That's why you need to experimentally do it, not just numerically. You can't just numerically divide or add the numbers, or divide or do whatever numerically. You need to physically, okay, move the ruler slowly until you find the center of mass. Okay, above the pivot, yes, you do it above the pivot. Okay, until the center of mass is reached. Okay, reached. Yes. Okay. Next question. We have he's investigating the cooling of water under different conditions. Can I find theta r, the room temperature? Yes, the room temperature is what? 21 degrees Celsius. 21 degrees Celsius. Okay, that's easy. Moving on to the next question. He pours 200 centimeters cubed of hot water into the beaker, records the time starting at time zero. She continues recording the temperature at 30 centimeter, 30 second intervals. The temperature readings are shown in the table. Complete the column headings, the time and the theta. Theta and time. So the theta is in degrees Celsius and the time is in seconds. 30-second intervals. What do I mean by 30-second intervals? She started off with zero. She started off with zero, and then you can just keep on adding 30, 30, 60, 90, 120, 150, and 180. He needs to make sure that you know table 3. Calculate the decrease in temperature between 0 and 180. Between 0 and 180. Can I find the decrease in temperature? Yes, 92 minus 67. 92 minus 67, which is 25 degrees Celsius. 25 degrees Celsius. Calculate the average rate of cooling using the equation. Okay, so I have the equation. Do I have delta T? Yes. Do I have delta T? Yes, delta T is 180. 25 over 180, which is 0.14 degrees Celsius per second. Include the unit. Degrees Celsius per second. Do I write negative 25? No, ignore the negative. Just ignore the negative. Okay, so 25 divided by 180 is 0.14 degrees Celsius per second. A student states that the average rate of cooling decreases as the temperature comes nearer to the room temperature, which is true. Suggest one change to the experiment that you would or you could make to test this statement. He's saying that the rate of cooling would decrease. So instead of being 0.14, for example, it would be a number less than that. Okay, it would decrease if or as the temperature comes nearer to the room temperature. As the temperature decreases, will that actually affect the rate of cooling? Yes, it would. How can I test this experiment? How can I test this experiment? You have several ways, but first of all, or actually the easiest way is to start with a lower initial temperature. Instead of starting off with 92 degrees Celsius, can I start the water with, let's say, 80 degrees? Yes, you can. Okay. So start with a lower initial temperature. How can I display them? How can I display the results to make it easier? Okay, displaying the results is always using what? Using a graph. That's why in planning an experiment in question, the last question, we always say, how can I compare the results by plotting a graph? So plot a graph of the temperature against the time. Plot a graph of temperature against time. Okay, how can I display the display of any result? How can I display the results? By plotting a graph. I can see clearly whether the temperatures, as the temperature decreases or as the temperature increases, I can see clearly how does the rate of cooling change. Okay, so if you plot the graph, for example, it will be somewhat like this. Okay, it will keep on decreasing. Explain briefly why is it a good practice to read the thermometer at right angles. Take the reading perpendicularly. Why? To avoid Hmm. To avoid parallax error. To avoid parallax error. The student uses a measuring cylinder to measure 200 centimeters cubed of hot water. She reads the scale at right angles. Suggests another precaution to obtain an accurate reading of the volume of the water. If you have a measuring cylinder, what are some of the precautions we take while taking the reading from a measuring cylinder? Take the reading from the bottom of the meniscus. Yes, take a reading from the bottom, mhm, of the meniscus. Oops. Mm, from the bottom of the meniscus. No, no, do not repeat more than once. You will repeat more than once, definitely, but as a precaution, the main precaution while dealing with or while using a measuring cylinder is taking the reading from the bottom of the meniscus and definitely taking the reading perpendicularly to avoid the parallax error. Hmm. Question 3. Student investigates the refraction of light using a semicircular transparent block. Okay, we have a ray trace sheet. We need to draw on this ray trace sheet. On figure 3.1, draw the normal through the center of AB. Okay, so just measure the distance between AB and find the center. Draw the normal, continue the normal so that it passes through the curved side of the block. Label the normal NL, point C where it crosses AB. Okay, normal would be somewhat at this position, this point. Okay, normal line, it has to be perpendicular above AB and below the semicircular block. This is normal and L. The point where it crosses CD, this point is called C. Okay, draw a line DC below PC. Below PC, can you say PC? PC. DC below PC at an angle of 30 degrees to the normal and to the left of the normal. To the left of the normal below PC. Okay, for example, so this is your, okay, you need to position the protractor this way. This is your protractor. Measure an angle of 30 degrees. 30 degrees would be around here. So when you draw the line, this is line DC. This is line DC at an angle of 30 degrees. At an angle of 30 degrees, okay, you need to probably have a longer line. Okay, this line should be a bit longer. Okay, DC. Mark with neat crosses X the positions for two pins, P1 and P2, at a suitable distance. Okay, we said suitable distances for P1 and P2 have to be at least what? At least 5 centimeters. P1 and P2, at least 5 centimeters apart. P1 and P2, these are the distances between them. Okay. Hmm. He looks at the position of the eye shown to observe the images of P1. Okay, P2, he places P3 and P4. The positions are shown. Draw a line joining P3 and P4. Continue the line to AB. Label E, the end of the line furthest from AB. Okay, draw a line P3 and P4 until it reaches AB. Let me use a different color. Okay, P3 and P4, they should be joined. They will reach point C. Label the point, he said what? E, furthest from AB, so this is point E at this side. This is point E. Okay, definitely use your ruler, use a pencil. Your pencil has to be sharpened, very thin lines, very accurate drawings. Measure the acute angle alpha between NL and CE. Between NL and CE. Can I measure this angle alpha? Can you measure this angle alpha? Yes, I think you can. Okay, using again your protractor, you have to put the protractor this way. Okay, 0 all the way to this line, to line CE. The angle would be around, it would be around what? 49 degrees. Should be around 49 degrees. Give or take 1 or 2 degrees. Okay, so it's if it's 49, if your angle is 48, 47, okay, 50, 51, again, okay, it would be acceptable. So the angle alpha is 49 degrees. State one precaution that you would take in order to produce an accurate ray trace. Again, what are the main precautions while drawing? Main precautions while drawing this ray trace. Definitely you need what? You need to use thin lines or view the bases of the, yes, use thin lines, view the bases of the pins. These are all correct. Of the pins, use thin lines. In this question, we do not say take the reading perpendicularly. Okay, we do not say take the readings perpendicularly. We actually say view the bases of the lines, which is quite similar. Which is quite similar to saying take the readings perpendicularly. Instead of saying take the readings perpendicularly, we say view the bases of the lines, which is bases of the pins. I'm sorry. Okay, bases of the pins, which is like saying take the reading perpendicularly. Okay. Student moves the transparent block to a new position on the ray trace sheet as shown in figure 3.2. He draws a line CF through the positions of P5 and P6. Measure the acute angle beta between AB and CF. Can I find or can I measure the acute angle between AB and CF? Yes, I need to find this angle. You need to find this angle. The angle, if you use your protractor, would be around, I guess, 71 or 72. Okay, angle should be around 72 degrees. If you measure this angle, calculate the angle theta between CF and the normal to AB. Okay, between CF and the normal to AB. Where is the normal? This is the normal. Okay, do I have to measure the angle? Do you have to measure the angle? No, you do not have to measure the angle. How should you position the protractor, first of all, to find angle beta? How can I find? You can position the protractor like this, semicircle. You should position the protractor in which you will measure 0, 10, 20, 30, 40, 50, 60, 70, 72. So it would be around 72. This is angle beta 72 degrees. Now he wants to find the other angle between CF and the normal. So should I draw the normal and measure the acute angle between the line and the normal? No, you do not need to do that. He didn't state that. He didn't say draw the normal and measure the line or measure the angle. How can I do that? I can just say 90 minus 72. 90 minus 72, which is 18 degrees. Okay, so if your angle was 71, you can just say 90 minus 71, which would have been 19 degrees. Okay, Sun suggests that the angle alpha should be equal to theta. Alpha should be equal to theta. Where is theta? Theta is 18 degrees. Alpha was 49 degrees. Okay, state whether your results support the suggestion. Are they remotely equal? Do I actually need to divide the larger number by the smaller number and find the limits of accuracy? No, it's quite obvious that they're not close at all. Definitely not equal. Not equal. Why? Because the numbers are far apart, or the values are far apart, exceeding the limits of experimental accuracy. Exceeding the limits of experimental accuracy. Okay, question four. A student investigates the change in resistance of a lamp when the current is increased. That's quite obvious. He's changing the current and he's measuring the resistance. Changing the current and measuring the resistance. The following apparatus is available. Okay, plan an experiment. Plan an experiment. To do what? To investigate the change in resistance when the current is increased. That's it. That's all you need to do. You will change the current, and based on changing this current, you will measure the resistance. He has given you the equation to measure the resistance, R equals V over I. R equals V over I. So the resistance R equals V over I, plan experiments. What should you do? Okay, what should you do for this experiment? You need to set up a battery. Okay, draw a diagram. Okay, so how can I draw the diagram? Set up a battery. I have the battery. Okay, the change in resistance of a lamp, of a filament lamp. So I have battery. Let's say that we have a switch. Can I? There is one apparatus that is very important that you need to add to this diagram. Okay, we'll have the lamp, definitely wire, but there is يعني an really, really, really important apparatus that you have to draw, which is what? Which is a variable resistor. Yes, thank you. A variable resistor. Why? Because the variable resistor, what does the variable resistor do? What is the function of a variable resistor to control the current? Variable resistor changes the resistance, but its function is to control the current. So you have to add a variable resistor. Okay, and now I have a lamp. Okay, and okay, you have to add the ammeter. You have to add the ammeter to measure the current, and a voltmeter to measure the resistance. The voltmeter has to be on the lamp. Why does it have to be on the lamp? Okay, because you're finding the resistance of the lamp. So this is a very simple. Do I have to add the switch? No, you don't have to add the switch, but it would be a good precaution to add the switch. It's not a must, but you have to. Uh, it's a good precaution. Yeah. So I drew the diagram, explained briefly how to do this investigation. Okay, so let's go on. First of all, let's say the range of values. Range of values, I'm changing the current in the circuit. Okay, I'm changing the current in the circuit. We can just add any values, 1 ampere, 2 amperes, 3 amperes, 4 and 5 amperes. So these are the different currents in the circuit. Range of values. You are changing the current. And then, do I need to state the controlled variables? He didn't say so. He did not say so. He said draw the diagram, explain briefly the steps, draw a table, explain how to find the conclusion. So he didn't state clearly whether I need to write down any controlled variables or not. I don't need to write down the controlled variables. I do not need to write down the um, apparatuses. Can I just go on and state the steps? How can I conduct this experiment? Okay, first of all, let's write them down. Steps. Measure, okay, or take the reading. Take the reading of the current I. from the ammeter. Take the reading of the current I from the ammeter and take the reading of the voltage or the potential difference of the voltage V from the voltmeter. So take the resistance, then measure or calculate the resistance. Calculate the resistance R equals V over I. So these are the very simple steps. Okay, very simple steps. That's it. Yes, that's it. And then change the resistance of the variable resistor and repeat. Okay. Change the resistance of the variable resistor and okay, repeat. When I change the resistance of the variable resistor, the current will change, and therefore I can repeat the experiment. Can I draw a table? Yes, I can draw the table. What do I need in the table? I need three things: the current, the voltage, and the resistance, and definitely I need to use the correct symbols. Okay, so we have, well, let's write them down. The current in amperes, okay, the voltage in volts, and the resistance in ohms. And the resistance in ohms. Okay. Last but not least, I need to write down a conclusion, a very simple and systematic conclusion, as we've said before. Okay. As we have said before, how can I write down the conclusion? For each current, repeat and take average. For each current, repeat and take, okay, average. Repeat and take average. Record the results. The record the results in the table. In the table. Compare the results. How can I compare the results? Using compare the results using a graph or by plotting a graph. Compare the results by plotting a graph. By plotting a graph of uh, current and resistance. Okay, current against the resistance. Okay, all good. All good. ماشي.